Okay, I'll just go through the list of people. Pardon? What was that, Gary? No? Okay. I'll just go through the list of people in this order, which I'll say me first. I'm Desiree. I'm the chair of FunGIS, and yeah, I work for Wet Tropics Management Authority on the yellow crazy ant eradication program, and I basically map their distribution, rate of spread, and yeah, do all the mapping for aerial baiting and hand treatment, and essentially try to map the success or new invasions of yellow crazy ants throughout the period of time of the program. So yeah, we're expected to be funded to 2026. So that's what I've been doing. And the next on my list is Gary.
Hello everyone, I'm Gary Searle. I work for Terrain NRM, and my role is data, mapping, project management, decision support, basically telling stories with numbers, pictures, maps, graphs, etc. And having a whole bunch of fun in Terrain, getting good outcomes for our community and environment.
Excellent. And
I'm the treasurer of FunGIS.
Most importantly. Excellent. And David Nelson, our speaker for today.
Should I just introduce myself in my talk?
Yeah, sure. Okay. All right. We'll put you can go last.
Yeah.
Neil Bride.
Hello. Yes, I'm Neil Bride. I'm largely retired, but occasionally work for a small consulting firm, and we're mainly doing environmental authority monitoring, I guess, for ERA, for various people who have an ERA. And it is mostly to do with mine rehabilitation monitoring at the moment. That's probably all it ever will be, but while I keep working.
Excellent. And Aidan Joseph.
Just unmute myself. Hi, yep. So Aidan Joseph, I'm based in Cairns. I have a spatial data services business that I run here, doing mostly fire mapping and other stuff that comes along. So I'm not sure if everyone's familiar with NAFI and the North Australia fire information stuff. So
they will be after this chat.
Yeah, so that's mostly what I'm involved with. But yeah, any other kind of small stuff that comes along with the mapping opportunities and data analysis.
Awesome. Yeah, I was happy to see your name on the list today, Aidan. Good to hear from you.
Cheers.
And Lisa.
I'll unmute myself, start the video. Tom's in the background. We don't want to share headphones, so he's here. You don't need to deal with him. We're down at Mission Beach. We are both geologists, got our own consulting company. I don't really know what else to add. We're just interested in what's going on, and we use GIS all the time. So that's us.
Yeah, totally. Map chats are so good for that, just getting general awareness of other GIS projects, and yeah, cool little networking platform. So cool. Tom, did you want to add anything more?
No, he's going no in the background. He can't be bothered unmuting himself.
Fair enough. Lisa and Tom.
Yeah,
and Torben.
Howdy all, Torben here in Brisbane, locked down. How nice is that?
I'm down here too.
Yeah. I'm actually in the surveying department in Energy Queensland in Brisbane, but I'm more interested in mapping, and I'm using I've just got involved in drones at the moment and trying to work out how we take the drone information into creating maps for work. So yeah, I'm just playing, but yeah, the fire management, I was down Eden. My folks were down, they moved to Eden in New South Wales just as the bushfires happened. So this is a bit of a interesting topic. So yeah, I'd be interested to listen. Thanks.
Yeah, it's quite timely. Oh, well, thanks for coming along, Torben.
Thanks, mate.
And it doesn't look like we've got a Hans yet, but that's okay. Well, he won't get off the hook if he does tune in at some point. Okay, well, yeah, it is 5:30 and we shall start the map chat. So yeah, I guess I'll hand it over to David Nelson, our talker for today. Thank you so much for jumping on board and sharing some of your projects with us from the Kimberley. Very much looking forward to hearing about fire management and how GIS and remote sensing helps. I will hand over to you.
Great, thank you, Desiree. I'm just, now that you've all seen my beautiful face, I'm just going to turn my video off. I'm going to hope that all the technology works, and maybe transmitting video will assist in that. Not transmitting video will assist in that. So I'm just going to turn it off now. All right, so yeah, just a little quick bit about me. I've got a background in ecology. I've worked sort of in a lot of remote areas, and worked quite a bit in the Simpson Desert, and more recently, in the last few years, I was over in the Kimberley, and then only in the last sort of 8 months or so, I've moved over from there to here. Based in Cairns now. So I'm employed by the Australian Wildlife Conservancy. Some of you might have heard of them. So I just want to flag that right now I'm talking not as a AWC spokesperson. This is all pretty much about techniques that are very commonly used in not just in sort of AWC's projects in the Kimberley, but in the various other groups out there, including the different Aboriginal groups and ranger groups. So I just want to flag also that I'm totally self-taught in GIS in general. Just sort of started getting into it a couple of years back with some drone mapping work that I was doing, and just kind of self-taught myself. And I guess I'm a little bit strange as well in that I learned on QGIS, unlike probably most GIS professionals who use mainly ARC and maybe have transitioned a little bit to QGIS. And one of the reasons I mention this is I just want to apologize straight up. I've probably got lots of horrible GIS habits that have come from teaching myself, and I'm probably doing lots of things wrong. So please feel free in this talk to jump in and say, hey, there's a much easier way of doing that, or something like that, or try not to tear your hair out too much if you notice me doing something very irritating. So anyway, I just kind of got into this topic in the Kimberley. AWC actually does fire management in conjunction with traditional owners over something like 4 million hectares over there. So it's a pretty big project, and I think, like a lot of people, wind up in the strange places in remote areas. You kind of get thrown into the deep end a lot. So that's what I've kind of done. So I'll just start with a few shout outs. And the first is, most importantly, to the traditional owner groups of the Kimberley. Don't know if you're aware, but the Kimberley is over 90% native title. So it's a huge thing over there. Basically, every management decision involves the traditional owner groups. And, pretty much every traditional owner group has a ranger group. And, these guys are legends, and they're sort of responsible for a lot of the on-ground work out there. So I'm mentioning it now. I'm going to probably forget to mention it later on in the talk, but, everything we do is with these traditional owners, with these rangers, and couldn't do it without them. The other really big shout out is to NAFI. NAFI is just this, it's a really sort of powerhouse of a resource that is used, many, many times every day by fire managers around Northern Australia. So I've used a lot of NAFI data in this presentation, and yeah, can't stress enough that it's just a tremendous resource. And check it out if you're interested. All right, so I guess the whole sort of fire story in the Kimberley begins with the rain. The wet seasons are really spectacular. It's obviously a wet, dry tropics area, and the wets are sort of, not that wet. The sort of 1,400 mils is the maximum right up in the North Kimberley, and sort of maybe 600 or so mils down in the south, where you're sort of getting more into the desert country. But it is a really, really strongly seasonal rainfall pattern. So you get next to no rain in the dry season. And those wet seasons are really a great thing to behold. Just great clouds building up, and really tremendous to see the not just the rain and the flooding, but the way the landscape transforms when everything goes from being the kind of traditional Kimberley scenes that you see in all the postcards, where everything's just kind of rock coloured, to the beautiful greens that you see in the wet. So, one consequence is that you get a lot of fuel building up in the wet, and then come the dry season, you get a lot of country looking something like this. You just get masses of fuel built up. I guess the other part of the fire story is lightning. So the Kimberley has just an obscene amount of lightning. I've actually got a little map here from the Bureau of Meteorology. You can see that the Kimberley is really it's the capital, it's the lightning capital of Australia. You compare it to somewhere like Cairns, there's probably something like almost 10 times as much lightning over there in the Kimberley. So fires are going to start as a result of lightning. There's a lot of dry storms, very sort of late in the year, and those are just going to start fires all through the Kimberley, basically. So you are going to get fire. Now, some fires are also deliberately lit, and they are deliberately lit sort of all through the year, including when they're least wanted. But yeah, that's just sort of the reality out there. So there's been this fire pattern in the Kimberley in the past, prior to about 15 years ago or 10 years ago, where basically most of the Kimberley was burning every 2 years. Sort of takes, in a lot of parts of the Kimberley, particularly dry areas, it can't burn every year just because the fuel doesn't build up enough. But pretty much, half the Kimberley was burning in 1 year, and then the other half would burn the next year. And it does depend on fuel type. Some of the areas like the Spinifex areas, they take quite a while to build up fuel, whereas the sort of taller grass areas can build up a lot more fuel more easily. And it is largely grass fires out there. So these are just some examples of late season fires. And they can be pretty spectacular. And what you're left with after a late season fire is, pretty much a, sort of burnt wasteland. A lot of canopy scorching, and not much left on the ground. So this is just a little map of fire frequency, and the green is an area that isn't burnt much, and moving into the yellows and reds, it's burnt a lot more frequently. So this is actually 2000 to 2012. And you can see that, sorry, I don't have a legend on there, but the more red areas are burnt pretty much every year in that period. Moving forward into 2011 to 2020, you can see a transition to much less fire. So that's a really great pattern to see, and I'll talk about some of the reasons why we've sort of achieved that in the community. Now, why are we doing what we do out there? One of the reasons is we're trying to mimic Aboriginal burning patterns that were going on there for thousands of years, got disrupted by people being moved off the land, and those patterns were sort of influenced by hunting behaviours and just lots of sort of cultural knowledge over the years. So we're also doing it for biodiversity reasons and carbon reasons. So what do we do now out there? We get around in choppers and use these little things called rain dance machines, which drop incendiaries over the landscape. So we'll talk about how we do that once I switch to the GIS software. And essentially those fires that we start when we do that aerial incendiary burning, that's in the early dry season, sort of as early as we can, and you get a much more you get a fire that's sort of really only burnt the grass. You don't get canopy scorching to a large degree, and you get these really patchy mosaic fires. So that's just a little background on why we're doing what we're doing. So I'll just switch over to QGIS and start talking about how we do it, some of the resources we use to do it. So one of the really cool things is NAFI and also Firewatch have some data from satellites and other sources available as WMS and WFS service. So I've just added in one of the useful things, which is lightning. So lightning strikes are actually, those locations are actually calculated, I believe, by ground-based sensors around the world, and they sort of triangulate on where they are. So that's a pretty useful thing after a storm. If you get a dry storm and late in the year, you'll check where the lightning sort of was, and then either sort of get out there and have a look and see if there's anything burning, or wait to see the hotspots. So hotspots are available from a range of different satellites. Not too much going on at the moment. There's only a few little hotspots around, but they cover sort of the NAFI and Firewatch hotspots sort of cover Northern Australia. So I've just got these here as a WFS feature layer, and I've just kind of coded them by time. So the most recent ones are in the last 12 hours, and then those ones are the most red ones, and then getting darker is getting towards a couple of days old. So those are, if we actually look at one of these hotspots and query it, you can actually see where it came from and when it was detected. So this is telling us that the satellite was the SNPP satellite, and it's got the date and time there that it was detected. That's a really useful resource. And these hotspots do have limitations. Obviously, they can't be detected through cloud. So if you get a big storm, but there's a lot of cloud still around, you may not detect the hotspots. Even for days. The other thing is location accuracy isn't very good. It depends on the satellite. Some satellites obviously have better resolution than others, and one of the things you'll kind of get a bit of a knack for is like working that out. You'll look at the satellite and you kind of say, oh yeah, it looks like it's on the east side of the river, but I bet it's on the west side of the river. I bet it hasn't crossed the river, and that kind of thing. So there's obviously like a trade-off as well. There's some satellites that are getting images like every 10 minutes or something. I think it's every 10 minutes for the Himawari satellite. It might not be quite that frequently. But a lot of them are only sort of once or twice a day. And then sometimes you might miss that satellite for that day. You know, it just the little slice of the country that it got detections for isn't quite the area you're interested in. So using the Firewatch website is really cool because you can actually see where those images are. I'll show you that a little bit later if we've got time. So those are the hotspots, which are very useful in both your early season burns and in your late season suppression. So when you might be thinking of going out and fighting fires. So you can actually see there's a couple of little hotspots here in the Kimberley, and those are, they could be from lightning strikes. There's still a bit of weather around there at the moment. Or they could be from early season burning. I'm not really sure if it started up in that part of the country yet. So the next very important resource that I'm going to show you is the Firestar Mapping that's done by NAFI. So there's a few different ways you can get it. You can use it as a WMS layer, or you can actually download it from the NAFI website as a shapefile. And I normally do that so that I can actually visualize it in different ways. So in this example, I've got these fire scars. So these are areas that were burnt in 2019. So I've got this shapefile for the 2019 year, and I'm just looking at the second half of the year. So these are the late season fires. I can add the early season fires in as well, obviously. And I often just display them like this, going from green to red, just so that I can kind of quickly and easily see what was an early season, first half of the year fire and what was a late season fire in the second half. So I'll just focus on this little area here for most of the rest of this. This is an area called Dumbi Mungadi country, which is the traditionally owned land of the Dumbi Mungadi people. And one of the big problems with late season fires is that they can just go for months. Nothing's going to put them out until you get real rain. So if something starts quite early, it can just burn and burn and burn, and it can burn vast swathes of the country out. So one of the things that we try and do is really break up the country into smaller areas. So I'll just show you some draft lines that we kind of drew through the country, trying to split up the country, trying to get out there and burn these lines in the helicopter and sort of break up the country into smaller paddocks. And selecting these lines is something that it's quite an intricate task based on fuel and geography, and where the rivers are, as well as the type of country it's in. Obviously, sometimes things like the wind and hilliness and that kind of thing all play a part as well. But we basically select these lines and try and see how we go with burning these lines through the country in the early season. So what I'll do now is try and do a little animation based on the early 2020 hotspots. So this is when we're getting out there and trying to burn those lines. All right, fingers crossed this works. So sometime in sort of, March or so, sort of February, March, it'll kind of get to the point where you'll start seeing a few little green spots appearing in the landscape. So you can't just sort of get out there and burn all at once. You kind of got to hit it throughout the season and often go back multiple times over the same areas. So starting to see a good number of hotspots there. And I should just flag, as I said, some of these hotspots aren't particularly accurate. So that's just about the middle of the year when we'll stop doing the early season burning. And I'll just show you a couple of cool things that we can use to actually see how well that worked on the ground. As I say, those hotspots aren't great. So what I'm going to show you now is called MIBR, which is middle intensity burn ratio. So it's a type of imagery. I'm not going to pretend to be an expert in it. Haven't actually generated any of it myself, but you basically choose two. It's a satellite imagery, one before the fire and one after the fire, and then there's a formula for what you do with different bands from that satellite imagery. And I think it was designed for Landsat, but you can do pretty much the same thing with Sentinel imagery as well. And this is what it ends up looking like. So it's pretty intuitive. The darker areas are the areas that have basically lost more, vegetation between the two images. So it's a really cool method, and it's obviously very high res. You can get in there really closely and look at how good your burns were, and how patchy your sort of fire breaks, if you like, are looking. So obviously NAFI also maps the fire scars from that early season burning. It's good. It's just often it's not quite as detailed as we really need. So if you compare this sort of detail to the detail that that NAFI picks up, it's quite a different sort of scale. So NAFI, I think each pixel is about 250 meters, whereas I think if this was Sentinel imagery, which I think it is, I think it's like a 10 meter pixel or something. So it's very good. So I guess the proof is in the pudding. I'll now show you some another little animation, this time of the late season hotspots. So the fires that burned in the late season. So you can see these hotspots starting to pick up. So this area is very remote. Most of these fires are, only starting from lightning strikes. There's really nothing else that can start them up in this area. So that was the fire season, pretty much in 2020, and it's really cool. If you look quite closely at certain things, you'll see how a fire started and was just contained by those scars there. It doesn't always work that well. Sometimes they do get out of the fire scar sort of containment lines, and they do cover a bit more area. But yeah, ideally, that's what you're kind of aiming for, is just being able to break up the country so you don't have really widespread fires. So I'll just show you a couple other little methods. And sort of tie that into a little bit of fire suppression and what we do out there. So just based off those 2020 fires, I've just got a few bits of Sentinel imagery here that, that I'll show you. So I don't know if any of you guys have used EO browser, which is a Sentinel, which is a Sentinel and Landsat and other imagery browser online. It's a really cool method, and I'll just shout out to this guy called Pierre Marcuse, who has published some scripts to use for that EO browser, which are, I think they're very cool. This is the script here. I don't understand most of it. It's just gobbledygook to me, but the good thing is there's these sort of preset band combinations for the Landsat imagery that you can just plug and play into the EO browser and see some pretty cool stuff. So that mainly what you're looking at is near infrared and shortwave infrared combinations, I believe. And just on this blog post of his, which you can sort of seek out and find, he's got some really cool examples of just what's possible with that, with those imageries, with those band combinations. You can go for sort of a very natural look, or you can get sort of more and more psychedelic if you want. And it's all about what works in the system you're working in, and what you're really trying to show. So essentially what I do is plug his code into the EO browser. So I can't see it. So this website is the EO browser, and I just lost the code, sorry. This is the script here, custom script written by that fella, and this is a combination that I really like, which is quite a natural looking sort of combination, and then you can essentially step backwards and forwards through time as well. So there was actually an image just taken today. I think it's about every 5 days on Sentinel, and you can actually see, if you have a look, remember I showed you there are a couple of hotspots in the last few days. If you zoom right in, you can actually see the fire scar there, just this little dark area is those hotspots, that first little fire of the season up there in Dumby country. And then you can download the images as TIFFs, georeference TIFFs, and plug them straight into your GIS program. So let's go back here. And we have a look for those hotspots. Right here. Yeah, there it is there. So it's a pretty cool way of being able to kind of, have almost real-time fire information out there. So when we're firefighting, you can see here, this is one of those, as I say, more psychedelic kind of versions of the Sentinel imagery. You can, get quite up-to-date imagery of where a fire is. You can draw your containment lines. You can say, all right, we're going to try and hold this fire up at this creek line here. And you can obviously overlay your Firestar mapping and that kind of thing to be able to get out there on the ground. What we normally do is just save PDFs of the from this mapping, save PDFs for Avenza, which we then use on mobile devices. So when you're out there on the ground, you can have this this info in your pocket, which is really good, because we're often firefighting at night, and very easy to get disoriented, and you see glows all over you and you don't know where they are, and having that geographical information really close to hand is just brilliant. So that's pretty much all I wanted to talk to you about. One thing I just forgot to say is I'll just point out like another use of that Sentinel imagery. Because it is on such a fine scale, it's really good for being able to see exactly where a fire burnt to, and you can sort of plan other activities off that. So obviously, like what I do is a lot of ecology. So this little fire here, I had some cameras set right out along this creek in this little rainforest patch here, and it's pretty good to be able to look at this high-res imagery and convince yourself that your cameras didn't just get burnt. I was just going to say, just in regards to the types of ecosystem out there, and this is sort of relevant to the planning, that NAFI Firestar mapping is also sort of results in these maps of the fire frequency. And this just shows really clearly, this kind of map here just shows you really clearly that there's certain areas, and in this case, this area that gets burnt a lot more frequently is basalt country. It's really rich soil, and you get that long grass. And then all these areas that don't burn as frequently are sandstone, so you get mainly spinifex, and that spinifex can take a while to build up a load fire, load of fuel that will actually carry a fire. So yeah, again, just those NAFI resources are really invaluable to all the fire managers in the north. So yeah, that's all I wanted to say. So happy to take questions.
Awesome, thank you. Yeah, that was awesome. I have a question.
Yeah.
It was going back to the lines that you were creating I think they were the lines that you're using as your fire separators to plan where the fire scars were going to be burnt.
Yep.
And you were mentioning a few variables like wind and geography and fuel consumption and that sort of thing. And I was just wondering, like with the generation of those lines, was that a manual process, or is there some sort of way that you've been able to combine all those variables to create those lines? I was just curious because it seems like there's a lot involved there, and I wasn't sure if you mentioned it or if I missed that.
Yeah, no, it's not automated at all. You can obviously, yeah, maybe there is an avenue for that in the future. At the moment, there's probably half a dozen people in the Kimberley that can do that, can draw those lines, just because it is kind of a fairly esoteric skill, and
Is it like a like ground truth or something, or is it?
Well, yeah, there is. It is a combination of knowing what's on the ground, being able to switch between 100 different layers. You look at fire frequency to see how much it, how often that area can burn. You're also looking at the geography, so the topography, to see what's there. Honestly, it's the guys that can do it. It's a bit, you watch them do it, and it's kind of, your brain just gets fried trying to work out what they're doing, because there is a lot of info that feeds into that kind of planning. Yeah,
definitely sounds like a whole other project on its own. And those lines,
I should say the traditional owners are contributing to that as well, and there's certain cultural considerations as well. So one of the things that gets done before getting out and burning is actually getting out to some of the art sites and cleaning them up and making sure that they're not going to get fires sort of getting into the caves.
Yeah. Do those patterns change with each season, or is it they remain relatively stable?
Oh, they change, every year. Obviously, if you compare the 2020 late season fires, you're going to see a very different thing to the 2019 late season fires. So you're going to draw your lines very differently. Just obviously some areas that, you get more fuel building up, and then you might be, it's harder to burn it in the early season. So you might try and burn it, earlier, because it's still got a bit more moisture in it. Like I say, there's a lot of considerations in those.
Yeah, well, it would obviously change from year to year if one of your core criteria was how recently the area was burnt, because that changes from year to year.
Yeah.
Any other questions?
Yeah, so wait a minute. How many different layers do you reckon you'd be taking into consideration when you were doing those lines?
Well, like I say, I'm not sort of the expert, but I think a lot of it, like a big part of it, is even just that local knowledge as well.
Because it sounds very similar to the problem we have in mineral exploration, where you've got a whole lot of different layers that sort of add up to where you should go and look for a certain mineral deposit, and you feed all the different layers in, and just basically by an additive process between those different layers, it tells you where the most prospective places are for. So it'd be, they call it prospectivity mapping, would be the same sort of thing. You'd be just feeding in all these different layers, and their interrelation between them mathematically would just tell you where to go, sort of thing. Similar sort of a process.
Yeah, right. That's really interesting. I can definitely see that improving moving forward. The other thing that is also improving is that Firestar mapping. So NAFI is very much aware of how fine this mapping could be, and they're starting to do very fine scale Firestar mapping as well in certain areas, and that's really important for fire carbon as well. That's a huge thing, because there's a lot of money in that. I think probably what we're going to see is more of a like automated fine scale mapping, sort of machine learning approach or something that's going to be able to do that.
Because you can do that sort of thing in a very simple way, or you can do it in a very complex way. But so you're sort of saying your intensity maps are basically mapping the geology, are they? In terms of those basalt units.
Yeah, it's there's a few things that play into it, but yeah, definitely that. I mean, if I were to simplify the Kimberley down to, you know, the two major geology types, there's the basalt areas and the sandstone areas. And the sandstone areas are just in general doing a little bit better in terms of fire frequency than the basalt areas, and partly that is the nutrients and the soils, and part of it is just that the sandstone areas are really broken up. The basalt areas are really heavily weathered, and the sandstone areas have like big sort of gorges and cliffs and gullies and exposed rock, and yeah, those areas tend to sort of stop wildfires a little bit more, a little bit better. But again, we're always kind of just trying to increase fuel age even in those sandstone areas as well. Things like spinifex just take a few years before they actually seed well. So yeah, it's not great when they're sort of burning in a couple of years.
So before humans arrived on the scene, what would a normal fire season have looked like in that part of the world?
I think there would have been a lot of early season burning for sure. There would have been obviously a lot of people. This area is just so richly, you know, so densely scattered with evidence of human habitation. There would have been a lot of people scattered through the landscape, getting out, lighting fires, probably almost all through the year. And as a result, just a really fine scale mosaic of different fire ages. There would have been.
So 100,000 years ago, what sort of fire season would you have had?
Well,
before humans arrived.
100,000 years ago, I mean, 100,000 years ago, this area would have been extremely arid. So there might not have been much fire because the coast was like a good 150 kilometers away, I think. So yeah, there was like, there's a little cave here on Coolin Island, which is a mine, which has red kangaroo fossils in it. You know, so this area was totally different. You know, that kind of long ago. But if we're talking sort of 10,000 years ago, if we were looking at, yeah, Firestar sort of maps, I reckon it would be, you know, you'd almost never see those wide scale, wide ranging fires. There would have been some late season fires for sure. Late season fires, I don't think they're the end of the world. It's only when you don't have a mosaic already sort of established that those late season fires could actually cover the kinds of areas that we see today. And there's definitely cultural information about burning for fire. So you might have seen, you know, pyrocumulus clouds where you've got a fire, you've got a massive amount of smoke going into the atmosphere, and that then causes clouds, and you get the big downpour, which is kind of great if you're a hunter and you want to concentrate the kangaroos and stuff into an area in a couple of weeks. If it's just been burnt and then it gets rain, it's going to be a bonanza.
Hi, David. It's Hans here. Sorry I missed a little bit of the intro, but you might have explained some of this. But the NAFI program, it runs across all of Northern Australia. So your work here, does it extend out into Queensland and WA? Well, are we in WA here, or is that just the NT?
So do you mean? So I work for AWC. You might have missed this bit. And I've just sort of chosen to talk about this work in WA.
Okay, yeah.
And certainly AWC's burning program is a big part of its management work over here in Queensland as well, and in the Gulf and the NT. In some regards, there's similar problems. In some regards, it's different. So one of the big things I reckon is that problem of lightning ignitions. just doesn't seem to be nearly as much of a problem as you go further east. So yeah, I mean, every part of the country is different, and I don't want to pretend to know anything about
That's fair enough.
other parts of the country. But I do know one of the properties that I'm involved with, which is in the Gulf country, just in the NT. The land manager there is very keen on wet season burning, and breaking the country up that way and getting out there when there's moisture in the ground, there's the trees, the tree bark is basically saturated, and getting out there and dropping incendiaries from the helicopter at that time of the year. And I mean, we're still learning. I don't think definitely don't think we've got the best system. We've only really been doing this style of fire management in the Kimberley, for 10, 15 years.
I guess that leads me to my next question though. Is this just those lines that you drew, that's all within the national park? So these dropping the incendiaries from helicopters and that, or does it extend out into the grazing properties, other tenures?
Yeah, good question. Basically, all through the Kimberley, there's big projects. AWC does quite a big part of the Kimberley with various local landholders and Aboriginal groups, as well as on the pastoral stations that we own ourselves. National parks do their own burning programs in their tenure. Aboriginal groups that don't have involvement with AWC, they often either operate on their own, or they operate with Kimberley Land Council, and they are operating their systems. And we all work together. We all do things slightly differently. You can see just if you look at this area just north of the Prince Regent River. I don't know if you can see my cursor. But this area here is National Park, and you can see that there it's a lot more haphazard. It's not so much trying to get lines in, it's just trying to get out there and drop some bombs. And then you come over here into Woonambul Gumbera country and Willigan country, and again it's going back to this idea of getting fire breaks in. So people have slightly different approaches, and sometimes it works pretty well and sometimes it doesn't. Sometimes even those early season burns, you might not get them in early enough, and those fires burn for a few weeks. But yeah, pretty much. I mean, I don't have sort of imagery for the whole of the Kimberley, but it's largely there's similar sorts of ideas getting around. Pastoralists, they're generally pretty happy to work with us, they don't see big problems with this style of management either.
Sorry, I was just going to say, when you're zooming along the helicopter dropping these things, these incendiary, do you sort of take into account previous results in similar areas where some areas don't seem to have burnt so well? Do you drop more of them in areas where you think it's going to be more difficult to catch things on fire, or not really?
Yeah, totally. You can see it from the chopper. You can see fire scars, and you can see fuel loads from the chopper. So sometimes you'll be, sometimes you'll tell the chopper pilot to go close to the creek because there's a bit more fuel there, and you think it'll catch. Sometimes you'll be a bit worried about that, and you'll be, moving out into the sparser country. And yeah, I mean, there's definitely that local knowledge aspect. And we don't want to burn the same areas every year. We don't want to have the same lines in the same places every year. We don't want to burn along creeks all the time. It's very convenient burning along creeks because especially if the wind is blowing into that creek, you can drop your incendiaries 100 meters out, and that fire will burn up to the creek, and then it'll stop. but you don't want to do that in the same way every year, or that creek will just get, flogged out, all the pandanus will be gone.
Yeah.
So yeah, there is definitely those sort of decisions that you can make from the chopper as well.
I could chime in with a little bit of info, I guess, about NAFI and how it relates to it all. And sort of you were mentioning about the I guess one thing is the difference in the resolution there. So you're using the Sentinel imagery, and the NAFI stuff is using MODIS, which is at 250 meters a pixel. But there is a lot more of this higher res stuff starting to get used, all across Northern Australia. And some of it is actually getting loaded up onto NAFI, which I think you mentioned there before.
Yeah.
So, so it's sort of moving forward, I guess you could say, with all of that, trying to incorporate all that sort of stuff. I guess the reason that NAFI uses the lower resolution stuff imagery is that it is, you can get 2 images a day basically. So you can, and it's a lot easier to map the whole of Northern Australia. But yeah, obviously this stuff is a lot better for the operational and management type stuff. And I was also going to say that you can, I'm not sure if you're aware, David, you can get a NAFI plugin now on QGIS. Which is kind of
and
the same as
they've got a phone app as well, which is pretty cool.
Yeah, so you can get, that's right, you can get the app on your phone. At the moment, it only shows current year scars and previous and last year's scars and the hotspots, and a few different base maps that you can put on there. But that's going to be super handy for that field work as well. You can sort of have it out in the bush offline and see whereabouts you are in relation to your scars or your roads and whatnot.
Yeah, for sure. Yeah, NAFI do really great work. I did have this NAFI fire maps loaded, and I'm not sure what I did, but it definitely crashed QGIS at one point. So that's why I didn't use it at all.
Oh, okay.
That's also, I believe these are all WMS layers, is that right?
Yeah, it's basically the same as the WMS, but I think it is a lot quicker. I haven't used it a lot. I'm more of an map user, but when I have tried it, it just seemed a lot faster than the WMS feed.
Okay, yep.
I guess as similar to the WMS, the data is only sort of viewable. You can't edit it or export from it or anything like that to use in your projects, basically.
You can save WMS layers down.
Oh, okay, and use the data to export it or edit it and things like that.
Definitely done it in the past, using the export save as function.
Yeah, because if you use QField with that, I mean, just tiling up data and just loading it onto a device using QField.
Oh, I started using QField before I left the Kimberley, and I never got very good at it. I think I had issues with imagery, with loading imagery onto it, and
well, give us a go if you want to have another go. I've got a bit of a how-to's floating around somewhere.
Oh, cool.
But,
great.
And but we've found that quite easy to do and quite useful.
Yeah, right. Oh, that'd be great.
And just another one with that Sentinel EO browser or EO hub.
Yep.
If you've got a subscription, I think it's a paid subscription, you can set up a WMS feed to bring into your GIS. So you can set it up to have whichever sort of indus or band combination, etc., whatever, and date ranges, and have that as a background map in your GIS.
Yeah.
I don't know if
did
you've
it.
played with that before.
Yeah, I did play with it. I think they gave me a 30-day trial or something of it. But,
Yeah.
Yeah, no, I think when I was in the Kimberley, we were always very concerned about download.
Oh, yeah.
Yeah, on the satellite NBN. And I was always a little bit reluctant to have those layers as WMS layers when I could just kind of find the one I wanted. And then the other problem with the WMS is you only get the most recent one, so you can't actually look back through time. Quite often those images are obscured by cloud when you most want them. So yeah, that was the other issue with it. But yeah, definitely helpful, definitely useful. So.
Yeah. So as an example, I guess when I'm doing the mapping for NAFI, I have that WMS feed from EO browser with Sentinel imagery for the last sort of say month or week, depending on which layer I turn on, and have just the most cloud-free image. So, and that's super handy just as a reference to look at fire scars, because yeah, the motor stuff's kind of hard to interpret sometimes, being so coarse.
Yeah, right. Yeah. And do you work much in areas with higher canopy cover? Because I know all this Kimberley work, it's a lot easier than working in areas where there's more trees, just to be able to detect those fire scars.
Yeah. So yeah, that is an issue. Like say up on the east coast of Cape York, through that sort of rainforest, or around here, Cairns coastal region, it makes it a lot harder to get the scars out, but it's still possible. Sometimes it just can't, I guess between canopy cover and cloud cover, they're the two major issues for Firestar mapping.
Yeah, righto. Yeah. And have you ever used MIBR in those? Does it work reasonably well or not at all?
No, it works well. Yeah. So it works well. It's not, I found that it's not so good in the desert country. Gets a bit tricky in the desert country because the scars seem to just disappear. Like, I don't know if it's when, say, the spin effects or whatever burns and then the ash blows away, or I'm not really sure what the cause of it is, but the desert stuff seems to be different to Northern Australia.
Yeah, right.
Yeah.
So I have a quick question. When you were looking at ways to, I guess, evaluate the impact of a burn, like an early season burn, the MIBR looks great. Were there any other tools or indexes or other things that you looked at that were also useful when looking at that difference?
I guess I quite like that those near infrared and short wave infrared images, where those scars can show up on that imagery very well, particularly in the wet season. So that's quite a good sort of quick and dirty method.
I'm sort of looking at something sort of maybe slightly more systematic. So we're in the terrain NRM, wet tropics. So if the MIBR isn't so great when you've got canopy, it may be slightly less useful in my part of the world. But we do have projects and things where fire is used as a management tool, and we're just looking for ways in which, you know, when we're looking at monitoring and evaluating, you know, the impact or effectiveness or whatever of those burns, trying to find some measures. MIBR seems like it might be a nice measure that we could look at using to help us sort of quantify the area and perhaps even the effectiveness then, or the difference, the relative difference, because obviously it does show more or less burnt to a degree, which could help us when we're just looking at our sort of monitoring and evaluation sort of stuff.
On the monitoring and evaluation side of things, I guess we do have a few metrics that we use. So we have a GIS guy in AWC called Terry Webb, and he does a lot of this stuff. Some of you might know him. And he and Tani as well. Tani's just left AWC recently, but I'll try and remember some of the metrics we use. One of them is the average distance to an unburnt area. So that's sort of averaged over a whole, you know, sanctuary, which seems to be quite important for, you know, for things like small mammals. There's also, you know, the proportion of the country that was burnt in a late season fire and in an early season fire. And you can kind of have, you know, vague targets for that, where you might want to burn sort of 25% of the country in the early season, and then you might sort of view that another, you know, 10 or 20% is acceptable in the late season. And then it also, there's a few funny metrics that I don't know whether they've got too much validity in terms of biological kind of ecological reality, but you can even look at like the distance, you know, the mean distance to an area that was burnt in the late season. You can also look at the mean distance that an area was burnt to, the mean distance that an area is from an area that is 3 years unburnt, so like a long unburnt area. So I think those are probably the 4 metrics that I can think of off the top of my head that we do use in that capacity.
Great, thank you.
And don't ask me about how to calculate.
Oh no, that's fine. We have capacity for calculation.
Great.
If I can just with some of those metrics again, there's the patchiness. Did you mention patchiness just then, David?
Yeah, so
like
that
that
mean distance, that distance to an unburnt area is directly related to that patch size.
Yep. Cool.
Alrighty, cool. All right, well, any more last minute questions before we sort of wrap things up a little bit? No? Okie doke. Well, thanks, Dave, for your time and sharing some very interesting information. Thank you. Really appreciate that. And for jumping on board to support Map Chats. And well, thank you everyone for tuning in for our March Map Chat. I think we'll be having our next one sometime in April. I will organize that and email out some more information when we have that sorted. And I guess until then, have a very excellent month, everyone. And thanks again, Dave. We'll
thank you all.
This Zoom Map Chat will be available on YouTube, on the FunGIS YouTube channel in the next within the next week or so. So anyone who's missed it will be able to have another look or see it for the first time, and go from there.
Thanks, everyone.
Thanks, Dave.
Looking forward to the next one.
Have an excellent evening. See you later, everyone.
Yep, thanks a
Bye.
lot.